Good morning, this is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. I am going to deliver about the topic double sideband suppressed carrier. So first, what is this double sideband suppressed carrier? So it is an amplitude modulation. It is amplitude modulated wave transmission in which only sidebands are transmitted and carrier is not transmitted. The carrier is being get suppressed. So the carrier does not contain any information and its transmission results in a loss of power. Thus only sidebands are transmitted that contains the information. This results in a saving of power. So it results in a saving of a transmitted power. So next is a generation of double sideband suppressed carrier signal. So a product modulator is used for this purpose. So the input to the product modulator is a modulating signal and another input is a carrier signal. So output is a double sideband suppressed carrier signal. So the baseband signal or a modulating signal is represented by x of t is equal to ax cos omega t, and carrier signal is represented as c of t is equal to ac cos omega ct, where omega m is a 2 pi fm and omega c is a 2 pi fc. So output of this product modulator is nothing but s of t is equal to x of t into c of t. It is a product of the modulating signal and the carrier signal. So the output will be having a ax AC by 2 cos of 2 pi fc plus fx into t plus AC ax divided by 2 cos of 2 pi fc minus fx into t. So the maximum frequency is fc plus fx and the minimum frequency is fc minus fx. And the bandwidth is given by bandwidth is equal to maximum frequency minus minimum frequency. So here the maximum is fc plus fx and the minimum is fc minus fx. So fc plus fx minus of fc minus fx. So the bandwidth is twice the maximum, twice the fx. So at the output, the double sideband wave contains a signal whose frequency is twice the frequency of the baseband signal, where fx is a frequency of a baseband signal. So the bandwidth is nothing but it is a twice the frequency of the baseband signal or a modulating signal. So we have two modulator which generates the double sideband suppressed carrier wave. First one is a balance modulator and second one is a ring modulator. So balance modulator will be having a 2 AM modulator. These modulators are arranged in a balanced configuration in order to suppress the carrier signal. Hence we call it as a balance modulator. The carrier without any information content is suppressed by the balance modulator. Its principle of operation is such a way that when two signals of different frequencies are passed through the nonlinear resistance, then an amplitude modulator signal with a suppressed carrier is achieved at the output. In case of ring modulator, the four diodes are connected in a ring structure. Here four diodes are D1, D2, D3 and D4 are connected in a ring structure. Hence we call it as a ring modulator. Two center tap transformers are used in this. The message is applied to the input transformer, whereas carrier is applied between the two centered tap transformer. For positive half cycle of carrier signal, diodes D1 and D3 are switched on and the other two diodes D2 and D4 are switched off. So in this case, the message is multiplied by +1. For negative half, the diodes D2 and D4 are switched on and the other two diodes are switched off. So in this case, the message is multiplied by -1. So the resulting phase shift is there in the double sideband suppressed carrier signal. So double sideband suppressed carrier modulators are also called as a product modulators as they produce the output which is a product of two input signals. The two input signals are carrier signal and the modulating signal. And next is a double sideband suppressed carrier demodulator. So what is a demodulation? It's a process of extracting the original message signal from the double sideband suppressed carrier signal. So it's a process of extracting the original message from the modulating signal. So the demodulator used here a coherent detector and Costas loop. First one is a coherent detector. For the coherent detector, double sideband suppressed carrier wave is given as an input. So here the same carrier signal which is used for generating the double sideband suppressed carrier signal is used to detect the message signal. And the process is known as a coherent or synchronous detection. In this process, the messages can be extracted from the double sideband suppressed carrier wave by multiplying it with the carrier having the same frequency and phase as that of a carrier that is used in the double sideband suppressed carrier modulation. So resulting output is passed to the low pass filter and will be getting a demodulated output, or it is nothing but it is a message signal. And next is a Costas loop. In Costas loop is used to make both the carrier and the locally generated signal both should be in phase. So Costas loop consists of two product modulator with a common input signal S of t, which is a double sideband suppressed carrier wave. So the other input for both the modulator is taken from the voltage control oscillator. So the output of the filters are applied as an input to the phase discriminator. Based on the phase difference between these two signals, phase discriminator produces a DC control signal. So this signal is applied as an input to voltage control oscillator to correct the phase error in the voltage control oscillator output. So therefore the carrier signal and the locally generated signal will be in phase. So that's all about the double sideband suppressed carrier signal. So the main thing is that here the carrier signal is being get suppressed and only the message signal is being get only the message signal, sorry, in case of modulation the input signal is nothing but their message signal and the carrier signal. So the output is a double sideband suppressed carrier. So here in case of double sideband suppressed carrier, only the sidebands are being get transmitted and the carrier signal is being get suppressed because the carrier does not contain any information. So without any information, if we transmit the carrier signal, only the transmitted power is being get increased. So we are suppressing the carrier and we are transmitting only the sidebands. So that's all about double sideband suppressed carrier. Thank you.